using plants to extract value from wastewater treatment. The human population is now over 7 billion, but there are limits to the resources the Earth can provide. Consequently, we need to find alternative ways to extract resources if we are to continue to survive. As waste generation increases in line with population, this gives rise to the opportunity to extract resources from the waste, which is beneficial both from a waste management and resource generation perspective. To this end, phytomining, an emerging technology, was explored as a potential option to achieve this. Current wastewater treatment plants extract resources from waste in the form of reusable water and biosolids for land application. However, the precious metal extracting processes are limited. A review by M.A. Barakat, 2010, found that current trends in removing heavy metals from industrial wastewater generally utilize physiochemical removal processes, including the use of adsorbents, membrane filtration, electrodialysis, and photocatalysis. This suggests that there is an opportunity to investigate the use of metallophytes as a quaternary treatment process. Environmental remediation deals with the removal of pollution or contaminants from environmental media such as soil, groundwater, sediment, or surface water. It is a field of environmental science that is generally applied to reversing the effects of contamination after the fact. However, the principles behind the science lie predominantly in the removal and extraction of the contaminant. The principles underlying removal and extraction to improve the contaminated media is what makes it such an important and growing field. Phytoremediation is a complementary technology to engineering-based remediation methods that utilizes plants and their associated microbes in order to stabilize, extract, degrade, or volatilize pollutants. One such mechanism is phytoextraction, where the contaminant is pulled from the contaminated media and sequestered within the plant body. Phytomining takes this phytoextraction step further by utilizing plants which have an ability to tolerate metals and hyperaccumulate them. This allows for the plant to extract and concentrate the metals into commercial quantities. Traditional phytoremediation for phytomining applications have always occurred in terrestrial environments. For it to be suitable in a wastewater treatment plant, it should be tested under hydroponic conditions. An additional benefit of a hydroponic installation is that nutrient levels, if controlled, can come from the wastewater treatment plant itself. This project aims to test the viability of a hydroponic installation by testing the extraction rate of a number of suitable plant species. This is done by cultivating the plants up to a suitable life stage, then by placing them in a hydroponic situation. After a suitable amount of time has passed, they will be harvested and analyzed for contamination concentrations. The impact of this project is that it investigates the applicability for phytomining as a complementary technology in the traditional wastewater treatment plant. It is beneficial because it adds a value-adding step to traditional wastewater treatment processes through a passive and low-cost solution. Further experiments would investigate the applicability to an actual wastewater treatment plant.